And thank you for joining this month's session in PractiTest guest webinar series, Info Testing Unleash, Elevating Software Testing and Compliance as a Code. I'll have Baldvin introduce himself in a short while, just in a minute. I will introduce myself first. Apologies, my name is Noah. I manage the marketing here at PractiTest. I do want to say a few words very briefly about PractiTest in case you're not familiar with who we are. So we are a centralized test management platform, enterprise grade, connecting any aspect of your testing. You're still, we can see you, Baldwin, but you are on upside down. Oh, now it's much, much better. Great. So what essentially PractiTest does, we're end-to-end, as I mentioned. You can connect everything from the planning and vision phase, requirements and user stories that can be either stored within our platform or within any platform you're working with, Jira, ADO, ClickUp, GitLab, etc., and multiple platforms at once. We see that more often than anticipated. You can execute testing from within the platform or even trigger automation testing from within the platform, and then report issues, because unfortunately we do find them occasionally, but that's part of what we do. More importantly, report and visualize and communicate those testing results to any stakeholders on the level they need to see very easily and very accurately. So this is one thing that I wanted to mention. A sample of our customers, just so you can probably find some that you know of and are relevant to your industry. This is a subsample, of course, but just so you'll know, we do occasionally, in addition to those webinars, we conduct live training and Q&A session in case you don't like to have a one-on-one session. If you do, you can also come to our website and ask for a dedicated session for yourself. But this goes on twice a month, so you can also sign up for this session. And last thing before I hand over to you is introduction about a next session on this webinar series, which will be next month on October 22nd with Gil Zilberfeld, who will talk about clean web testing. And without further ado, we've met today to hear from Baldwin. So handing over to you, I'll stop sharing. If you don't mind, start by introducing yourself, a few words, and then let's give it a go. You're still on mute, just for one less technical challenge for today.
Yeah, very sorry. I had to join by my phone as I had some technical issue with my laptop. Did you get the slides so you could share them for me?
I actually did not.
Okay. Then we have a little bit of a technical challenge. I sent them to May.
I can try.
Let me see. So first of all, welcome. My name is Baldvin Gislason Bern. I'm consultant in cybersecurity and testing. I've been working as a tester for more than 20 years and in cybersecurity for over 10 years. And one of the things that I've gotten really interested in recently is the importance of information quality and information quality in general, and how testing can help with that. So that's what my presentation will be about, if we can get it started. Do you have anything, Noah?
I don't have on my end, no.
Okay, I will share the link with you, and let's see if we can get that working.
Yes, that would be great.
So you should get the link. So while we're waiting for the technical issues, I'll tell you a little bit about the story behind me getting into information testing. So it all started with me realizing that the company I was working for at the time had been spending so much time on software updates and so much time on testing and making sure that the quality of the software updates were up to standards. And then when I started investigating a little bit what the customers were using, it turns out that they were not updating to the latest version of the software. And the reason for this is that an important partner an important partner where the customers are using the software as well, that partner was telling them that they should be using the older version of the software. So all our effort on working on testing new updates of the versions and all the work put into it got stopped for the single reason that a partner had an error on the web page. And I started looking into this more and more and found that testing information is something quite important. And then with my work in cybersecurity, I got working into compliance source code, which is basically the same thing. So we can start with the first slide. What is testing information? When I say to people they should test information, they ask me, what do you mean testing information? Next slide, please. First of all, let's just figure out what testing is. For different people, testing means different things. When I say testing, I typically mean that you have to discover some sort of expectations and see if they are met. Try to figure out what's supposed to happen if I press this button? What's supposed to happen if I do this? And then you test to see if this is met. Next slide, please. And what is information? Well, information is just structured data that has meaning. There are two different but important aspects here. One is the structured part, and the other is the meaning part. Next slide, please. So basically, testing information is discover expectations that are on the information, that is the structure and meaning of data, and check if they are met. This is not that dissimilar from testing a pen or testing a bicycle or whatever. I'm sure that most people that work with testing software would not feel uncomfortable testing a pen. So they should not be uncomfortable in testing information. Next slide, please. It's important to note here that when I'm talking about information, I'm talking about information at scale. Sometimes we have information in human-centric documents such as Word documents, Confluence, etc. And basically, when people are reviewing them, they are testing them in a way. I'm not that interested in previous slide, please. I'm not that interested in decisions in source code or similar, but I'm rather focusing on information at scale in computer-readable files or databases. Next slide, please. One example of information is the one that I was giving in the story in the beginning. Which version of product A and product E work together? If you're doing software for Android or Apple or Windows, then Microsoft, Apple, and Google will be taking care of this for you. That's one of the things they do. But in a broader aspect of system development, for example, if you have some sort of embedded systems or factory software or a lot of different kinds of software, the question becomes which version of product A and product B work together. This example could also be which features does a certain product contain. The exact example is not that important. Next slide, please. Another example I will be going into a little bit later is the example of compliance. Is product A compliant to regulation? Now, if any of you listening are working in a company that's highly regulated, like automotive, medicine, or similar, then there are already people taking care of compliance for you, and you probably haven't noticed. If you think the company you work for does not have to think about compliance, that's unfortunately wrong, as there is regulation coming in the European Union and worldwide, basically, that forces company that make software to work on cybersecurity in a way that enforces compliance. And I will talk a little bit about that and how testing can help. Next slide, please. So before going into detail about the examples, I want to talk a little bit more about the quality attributes of information. So there are, of course, a lot of quality attributes to software in general, and information is no different. Usability, usefulness, etc. I'll be focusing here on the correctness aspect to make sure that information is correct. Next slide, please. So why is information incorrect? You could argue, and I hear people argue a lot of the time, the people that are responsible for the information should just make sure that the information is correct. Click, please. But you could also ask, why do programmers introduce bugs? It's not that the developers do this on purpose. It's just the complexity and scale. Click, please. Complexity and scale makes it almost impossible to make software without making mistakes. And that's why testing is needed. Information is quite similar. If I ask you to write your name, I'm sure you can manage without errors. And it's because your name is kind of simple and you've had a lot of practice. But if I ask you to write 10 pages of text without any help of autocorrect or spell check, I'm pretty sure you would have difficulty managing without making any typos. So complexity and scale is basically what makes information incorrect. Click, please. And testing can help, and I'll show some examples of this. Next slide, please. Information correctness, I mentioned the structure and meaning, and if you click, then we'll see that syntactic correctness is the first thing I want to mention. Click, please. Correctly formatted is basically what syntax means, so that it can be processed. So I'm speaking in English. If I would be speaking in a different language, then you could probably not process the information at all. On a computer terms, it has to do with the syntax, be it programming syntax or file format, etc. Click, please. The other type is semantic correctness. Click, please. Where the meaning is what we expect it to be. And this is a little bit more tricky, but if we cheat, it becomes easier. Next slide. As a side note, I'll just mention that data swamps, which people may or may not be familiar with this concept. It's data, huge amounts of data that are very, very difficult to work with. And a lot of companies have their business model just basically taking care of this data. And it's usually, the problem is that the data lacks syntactic and semantic quality. This is a general problem found in a lot of places. Next slide. So when testing information, my first example will be about a direct approach. You just simply test the information like you would be testing a pen or testing software. Just use your tester skills. Click, please. I'd basically just say pre-intend the software, and then I'm sure all testers that are worth their salt could actually test the information. But of course, that's not that helpful. So I will give some practical advice. And it's important for me to note this, to make the disclaimer that it may be different for different people. Of course, the examples I am giving you have been helpful in my context. Copy pasting is probably not that useful, but I'll hope to give you some ideas. Next slide. So I was mentioning the syntactic and semantic correctness. I will start with, and the reason I'm mentioning this again is that it's very important to try to understand these two aspects. of information quality, the format, and the meaning. We'll start with the syntactic correctness on next slide. So having information correctly formatted is not a technically difficult problem. It's not like making a huge amount of software that does complicated things. This is actually very, very easy, and from a technical point of view. The problem is that this is a people problem. And the way it is a people problem is that people prefer to not have to follow a certain format. They don't see the usefulness in it. And sometimes people see the usefulness in it, but they do not follow the most basic thing for correctly formatted information, which is schemas. On next slide. Schemas are basically common definitions in computer readable format. So some of you that are as old as me might recognize the XML example that I have here. That's not that cool and hip. So most of the examples I will have later in the presentation will be in YAML, which the young people, I understand, prefer over XML, but it doesn't really matter. The important thing is that having a clearly defined format, and it does not only mean choosing a format like XML or YAML, but rather creating a schema. On next slide, I have an example of an XML schema. It shows an element book. This is something you would typically see in a school book to explain what the XML looks like. The schema defines that a book has a title, author, a price, and a published date. Creating a schema like this is kind of trivial, but the problem is usually with the people. The common definition in part means that different people have to agree. But as long as you get the different people to agree on the common format, then the syntactic correctness part just becomes schema validation. In XML, schema validation is built into the whole structure of the language, so to speak, or the XML format. For a more user-friendly, in some ways, formats like YAML, there is not a clear schema validation tools available, but you could basically just write a short linter or similar that fulfills the same purpose. So from a technical point of view, this is trivial as long as you can convince people to do this. Next slide, please. Semantic correctness is a little bit more tricky because then you get into meaning and what does information actually mean. But we can cheat a little bit. Next slide. Semantic expectation can to some extent be expressed with logic. Now, of course, not everything can express in perfect ways in logic, but we're not trying to achieve perfect. We're trying to go from something is terribly wrong to something is mostly not wrong. Next slide, please. What I mean by logic is something very, very simple, like a rule like this. If you expect something to be true, then you might expect something else to be true. If it walks like a duck and quacks like a duck, then it's a duck. And as with the duck example, it's not entirely certain that it will cover every single instance, but for the most parts it will. For the interoperability part, as an example, then you might have to first find out which versions of product A and product B are interoperable, and then expressing it in computer readable format. And this is where things sometimes go wrong. Instead of sending somebody a free text email and they will update the web page and nothing is in a clearly defined format, it's actually quite easy to express in a computer readable format. And we have an example on next slide. Something like expect if product A version is 4, then you have to have product B version 8. And as I mentioned before, because of a error on a website, none of our customers were updating their software. And if you express this in a computer readable file, then you could get something like on the next slide. Here you can see in a YAML format, we've decided that the rule should have a name and the rule should have a condition, and then you express the condition in some sort of a logical way that is clearly defined so that anybody that's using the rule will understand what it means. Now, people that work in testing and have done some test cases and similar, they might actually notice that this is quite similar to approval criteria in test cases. You expect that if you push a button, then something will happen, and then the test does something. But I will explain later why expressing in it rules can be a very powerful thing when it comes to information. Next slide, please. Now, I've mentioned this example many times about a website being out of date. Some people like to solve this with saying that there should only be one source of information, and that that will solve every problem. Click, please. So in some cases, the databases, for example, for different companies' websites, they will be running on different servers managed by different companies. So expecting them to have the exact same source is not feasible. But you can, again, express the expectations quite easily in a logical way. If database 1 has a certain value, then database 2 should have the same value. And this is basically quite trivial. This is completely trivial, but for some reason, people do not do this enough with information. Just to show you an example how short and easy this would be as an automated test, we have the next slide, where we have, next slide, where we have, the code is quite tiny, so you might not be able to read it, but that's not the point. The point is some sort of an automated test that gets the value of one database and then compares it to a value in another database is all that's needed, really. Next slide, please. And again, I'll be repeating this a lot because I find that people get stuck on its information, so I can't test it. People can use their approaches to software testing in a very much similar way, test the information. And the information is just easier to test because it's not as complicated as the software. Next slide, please. But what about scale? Testing like this on a really large scale, if you have a huge amount of information, is not really scalable. Next slide. And one of the example is this compliance thing. And I promised I would mention why you have to care about compliance if you work in software development. And the terrible words are on the next slide. The Cyber Resilience Act. So if you work in the European Union, or if you export or sell anything to the European Union, you will have to fulfill the Cyber Resilience Act, which is a European Union legislation that's coming this year. The companies will have 3 years to adapt to it, so there's no need to panic yet. But for product development companies, 3 years is not a lot of time, especially if you haven't gotten started on cybersecurity already. So I don't want to bore you with all the hundreds of pages of the European Union legislation. But I will bore you with the standard that the Cybersecurity Agency of Europe has mapped it to, which is on the next slide, called the wonderful standard EN 303645. It's just an example, so there's really no point in you in worrying about exactly this standard or another standard. The important thing is that here we have 137 pages PDF document of things that you have to do, and people have to keep track of it. So what do compliance people usually do? Well, that's on the next slide. They usually take the things in the standard or the regulation and make a long list in a Word document or an Excel document or a Confluence page. And you will have a table, something like this, that lists the different things that you have to do. And then are they mandatory or not? Are we doing it or not? And how do we know that we are doing it? And one of the problems with this is that it's a human-centric document. Next slide, please. And traditional compliance audits are really traditional. They really love PDFs, and they really love people filling in reports. And it's just not going to be feasible for some software development companies to suddenly have in their continuous integration pipeline some filling of documents in an Excel sheet. So what we need to do on the next slide is when we do compliance at scale. So if you suddenly, somebody tells you that you have to start working on this cybersecurity thing, for example, or you're doing other kind of information testing at scale, it's okay to have a Word document or an Excel sheet or a whiteboard or whatever when you're finding out what people expect. But when checking that if that expectation is met, it only scales if you move over to computer readable formats. And next slide. And basically, compliance as code is a bit of a buzzword and will become a huge buzzword in the coming 3 years as this European Union legislation kicks in. It's basically, my definition of it is you define compliance rules in a computer readable format, and then you run automated tests to check if the compliance is met. Of course, you could, in some cases, have some manual tests as well. That's not the point. The automated check of compliance is the important part. I'll explain this a little bit in detail. Next slide, please. So we take this kind of Word document or Excel sheet or whatever we might have created to figure out if our company actually follows this standard or this regulation. And then, next slide, we make it into a computer readable format. So this is basically the same thing. If you can see the text, it has some references to the standard, some sort of a name. Do we do it? Is it mandatory, etc.? One very important difference here is that in Word documents or Excel files, people have a tendency to just write some sort of a string to reference some sort of internal documentation or internal artifact or test case or whatever. That is a proof point. Once you go over to computer readable files and you want to be able to check it automatically, it forces you to make a clear mapping. So the mappings here are just some references to internal and external websites, but it could be to Jira tickets, test cases in a test management system, automated test cases in code repositories, etc. So you link your proof points that prove that you do the different things to some artifacts that people do in their daily work. Next slide. Well, the important thing of doing this is how the scaling comes in, that when you have this sort of a schema, then you can collect from the different resources, like the test management system, the Jira, or the whatever ticketing system you're using, and other artifacts, you can collect the information. And this is not very difficult to do. There are already open source alternatives that do this in different ways. Backstage by Spotify is one. But I've seen a summer worker do a whole system like this in just 3 weeks. So it's not a huge amount of code. Again, these are not technically difficult problems. It's just that people seem to not want to do them or not realize that this can be done. So once the information has been collected, we can test it. Next slide. And then we are back to a very similar and simple thing as we had before, in the example before. One thing I want to mention is that the rules, next slide. I can really recommend to try to have the rules outside, and this would mean basically that the approval criteria is outside the test, could you also say. And the reason is for this is that the rules can be owned by the compliance people, for example, a lawyer or some sort of a person that's not very technical and doesn't want to work with code. And it makes it much easier to separate the actual tests or the test code from the rules. Next slide, please. So the rules could be something like this. Again, very similar as before. This is YAML format. You could have it in any format you like, as long as it's clearly defined. And in these examples, we want some test case that's referenced. Maybe we have a test case that proves that our product does not have a default password. And we want to make sure that the test has been passed in the last 30 days. The other example of a rule, we just want the web page to return 200 OK. We don't actually go into detail in checking if the web page contains everything we expect, just that marketing hasn't moved it so the URI is broken, or the link is broken. And by having these rules, we can automatically check them. Next slide, please. And it becomes kind of trivial, actually, to test this kind of information. Next slide, please. At least compared to software. When testing software, we all often have much more complicated scenarios. And people have managed to do it quite easily. And information is really no different as long as you create schemas, you work with it in an organized way, and you really take responsibility for the quality of information, not only the quality of the software. So now we're on to the almost last slide. So the takeaways. First one. Click, please. Information quality is important. I'm sure most of you have run into this kind of an example at some point that some information is wrong. And it's important to not then just shrug your shoulders and say, well, the person that is responsible for it should just do it right. Even worse when people start keeping their own versions of the information because they know what's right. We should treat information quality just as important as software quality in general. Second takeaway, click. It's not technically difficult. So some of the things I've shown here might be new to some people, like schemas and stuff like that, but it's not a technically complicated thing. Doing automated collecting of information is not a very technically difficult thing. And doing automated tests for these checks is not a very difficult thing compared to automating software testing in general. It's mostly a matter of attitude. And finally, I want to mention that my final takeaway, click please, is that testing can help. I've shown some examples of how testing can help. I think if most of you would have figured it out yourself, if you would just forced to work with information, or if you got, like me, the interest to work with information and information quality, that a lot of the practices that we have, the methods, the tools, the ways of working we use with software is just as valuable for testing pens, softwares, bicycles, or information. And with that, I'd like to open for questions.
Thank you. I have some question written that I like to ask from the audience. It's very almost expected one, but it's all about AI those days. Can AI be possible? Can possibly use AI to enhance this?
Yes. So people are really excited to use AI for everything, but there are two issues with that. First of all, the issue is that the information is not that complex that you need AI for it, really. AI can be useful if you have huge amount of data and you can get an approximately correct answer. But I'm pretty sure that the legal people for compliance, for example, don't want to have approximately the right answer. Also, it's kind of difficult to understand how the AI got to the result it got. So AI is more useful when you either can see immediately if the result is okay or not, or if you don't care, like if you're generating pictures for a PowerPoint or something like that. So I would say that AI is overkill and not the best tool for this. But a very good question. Thank you.
I tend to agree. I think that at this point in general, I just did a webinar last week along with K2View about AI in software testing. And I think that at this point, AI is not replacing, it's not there yet to replace us. In some scenarios, in some contexts, it can augment us in our capabilities, but it's not a perfect match for every scenario at this point. 100% agree with you. Thank you for this. I have one additional question about schemas. Are there scenarios that they don't match? Okay, you've mentioned before regulated industries in the context, of compliance, but are there specific scenarios when you don't recommend using schemas?
Not really. So there are schemas mean different things to different people, but as I mentioned several times, schemas are basically just computer readable definitions that people have agreed upon. So if it's not important for people to agree on something, then you don't need a schema. And if you're not working on scale, you don't need it computer readable. But if you're working at scale and people need to agree, then you need a schema. And this is also why it becomes a people problem, because suddenly maybe legal and marketing and sales and developers all need to agree on the common definition. And then they have to work with the common definition. And this is why it becomes a people problem rather than a technical problem. And that would be a whole nother presentation to go into details how to solve that. But I think the important part is that even if people can't agree, then trying to make the schema will show you how people view the same thing in different ways.
That can be a tool for alignment.
Yeah. Yes. So I would always agree, at least trying to make a schema.
Great. It makes perfect sense to me. We actually don't have additional questions at this point. So I'd like to thank you, Baldvin, for the session, which was very insightful. Apologies for a few technical challenges that we had for our audience. Thank you for being with us. We do invite you to join us for our upcoming webinars, to come visit our website. And we will share the recording with people so you can revisit the session later on. Thank you for being with us, everyone. Good morning or good afternoon, depending on where you are around the globe. And thank you for today.
Thank you.